As I pointed out, there's your login. If you're new, there's your password if you're new. If you're not new, and you can change the password once you get in there. You click on your name up in the right corner, and you can change the password to whatever you want it to be. But there it is. The first time for your new students, the password is there on the screen. And again, just use the first part of your email that's circled as your login name. As your login name. And the link is right there in Google Classroom. So, all right, we're going to jump in and take a look at our curriculum, jumping into our Algebra 3 stuff, all that fun stuff today. So we're ready to rock and roll, get our semester going. I looked in there and there were some, I don't know if I was half asleep, but I did the due date. I already had like we started last week. So I changed the due dates to be correct. So our first ones are not due until the end of this week. If you looked in there earlier and saw you had a 0 because you didn't turn in assignments last week, that was wrong. I fixed that already. So that is now corrected. You won't have issues with that anymore. In Buzz, on our Algebra 3 class, I'm going to go to the grade screen just so we can see what's due this week. I'm going to click this little icon. You can also go up here in the menu bar if you want to do it that way, but this will get you to the same place. This is our first unit this semester. We're going to start with Module 5, Sequences and Series. Today, you see, we have 2 assignments. We're looking at arithmetic, sequences, and series. We're going to put them together if we can get through them all today. I haven't looked to see how long the lessons are. I was just trusting that we can do this. Next week, we'll look at geometric, and then we'll look at some sigma notation, graphing on the week after that. So, and then we'll get to the practice test and testing when we get into February the 8th, that first week. But this week, we're going to look at 5.01 and 5.02. And if the lessons are longer than I thought, we'll have to adjust the dates. But we open up this little folder down here. This has all of our lessons and assignments. The lesson is first, followed by the assignment. The lesson says lesson. The assignment doesn't say assignment, but it's a different icon. Arithmetic sequences. Oh, this is fun. In the following activity, you're going to be shown a list of numbers. So I'm going to open up the chat so I can give you guys an opportunity to respond on this. This is known as a sequence. We're going to see a sequence of numbers. Your objective is to identify the pattern. So you can give me the next numbers here. I'm going to make this a little bigger on the screen so it'll make it easier to see these numbers. That's probably about as big as I can make it. All right. Find the next 3 terms in this sequence of numbers. So we have the numbers 8, 23, 38, and 53. What is going to follow that? What is the next 3 numbers? You have to identify what the numbers pattern is now, right? What's happening with the sequence of numbers? What's the difference between each one? What's the pattern? Put it in the chat. All right, Paisley's got us started. Paisley says it's 68, 83, 98. Yes, I can. So I'll open up the Go Guardian chat. Tell you, if you put things in the Go Guardian chat, I don't always have time to monitor it because it doesn't pop up on my screen. But I try to look at it from time to time during class. So letting you guys know. But I do read all the messages, but sometimes it's towards the end of class before I get to it. So it is open. All right. Anybody else think? Everyone's going to just trust Paisley? No one thinks anything different? Let's put in Paisley's numbers here. 68, 83, 98. This is the class participation portion of class, by the way. All right, let's submit this. Excellent. All right, we got another one. See if it gets any harder. All right, people. Put it in the chat. I expect all of you to be putting in this chat, not just Paisley. Good job, Paisley. -5, -7, -9, -11. What's the next 3 numbers? These are not trick questions, by the way. Not trick questions. All right, there we go. Some good responses there. So we're saying -13. negative 15, negative 17. All right, all of you who said that, let's see if you are correct. Absolutely. This is not that hard, right? It's not that hard. Let's see what the next one is. Oh, get a little harder now. Not really. It's still just a sequence of numbers that has a pattern. It's just that now we're dealing with decimals. It's not any harder. It's just different. It just takes a little bit more thinkering, maybe, or a calculator. And it's going from positive to negative. Starts with a 3. Our last number is a negative 0.75. So where are we going next? What's after the negative 0.75? Have you identified the pattern? Yeah, we were quick on that last one. This one's making y'all slow down just a touch, isn't it? Says the next one is negative 3, negative 4.25, negative 5.5. Is that right? Right now, you're our only answer there. But we'll see if anybody else agrees or disagrees. Nobody? Oh my gosh, the class participation portion is dying. I should take attendance by using this chat. That would be interesting. So I was going to agree with you. Oh, everyone's going to agree with you. All right, I'm going to put these numbers in then. Since everyone thinks you're correct, but it's wrong. Oh my goodness. These numbers are incorrect. It says all of them are incorrect. That means I can count the whole class wrong because nobody disagreed. Oh, Pearson's got us a different answer. Xander's going a different direction. Sydney. Xander, I think we're already lower than negative 0.5 right here. So the next one wouldn't be negative 0.5. I think you got off somewhere. All right, I'm seeing, I think we're off by 1. I'm seeing people saying negative 2 instead of negative 3. Negative 3.25 and negative 4. So maybe we're just off by 1. Let's see. That's it. We were just off by 1. All right. Nice correction, folks. Nice correction. Yeah, we just got a little bit too far. Let's see, I think we have this is our last one. Now, don't let this confuse you. They put all these weird dollar signs in here. I don't know why there's $2 every time, but there shouldn't be. This is 2.5. This is 3.25, and this is $4. $2.50, $2.50, $3.25, $4. And this is not good modeling because he says that the answer is a fraction, enter the decimal. Well, they should have given us the decimal themselves, but they didn't use decimals, but they want us to do decimals. Okay, so we went from $2.50 to $3.25 to $4 to what? How do you find the pattern? Well, if you want to know going from here to here, you just go backwards and subtract. What is 3.25 minus 2.5? What is 3.25 going to 4? 2.5, 3.25, 4. We're going up. Starts at 2.5, goes to 3.25. Next is 4. So it's got to be something bigger than 4. All right, 4.75. I'm seeing 5.5, 6.25. All right, let's see. There it is. So we're adding 75 cents each time. Adding 75 cents. The third number was $4, so we went to $4.75, $5.50. All right. Good job. We got there. We got a little confused from time to time, but we made it. So we're going to talk about how can an expression or process be determined for an arithmetic sequence? What functions combine to create an explicit formula? That's going to be important. And what restrictions exist on the domains and range. All right, so the important thing here, and I'm going to make this big again because we need this. We need to be able to identify an arithmetic sequence from some other sequence that's not arithmetic. An arithmetic sequence, you add or subtract the same number every time. Well, you add every time, but you may be adding a negative number, which really means you subtract. Like that last sequence, we added 75 cents every time. Every time, 75, 75, 75, 75, 75. So with that in mind, this sequence here, all you got to do is put yes or no. Is this an arithmetic sequence or is it not? Is it some other kind of sequence? All right, Jaden was quick on that. So is David Lee, Alexander, Kaylee. Everyone's saying this is not arithmetic because it goes 1, 2, 4, 7. That's not adding the same number every time. It added 1, added 2. Yeah, let's say no. How about this one? Oh, goes from 3 to negative 147. And from negative 147, it goes to negative 297. And then it goes to negative 447. So it's getting smaller every time. It's going negative. Oh, but you guys say this is arithmetic. So it must be changing by the same amount every time if it's arithmetic. So 3 to negative 147 looks like it's subtracted 150. And then from negative 147, yep, Jaden's identified it. He said this subtracts 150 every time. So this is arithmetic. Every time we're subtracting 150 to get the next number. Good job. Every time we do the same thing. How about this? 10, 8, 12, 10, 14. Is that arithmetic? Those are all even numbers. We got 10 on there twice. You couldn't have the same number twice unless you're doing something different. You subtracted 10, you added 4. You subtracted 2, you added 4, subtracted 2, added. No, that's not arithmetic. That's terrible. How about this one? 4, 14, 24, 34. Yeah, we can see that pretty quickly, right? That's adding 10 every time. Plus 10, plus 10, plus 10, plus 10, plus 10, plus 10. That is arithmetic. All right, there you go. And it talks about the sequences right there. Adding 10 every time. That is arithmetic. This is not, because it adds 1, adds 2, adds 3. This one has a common difference of negative 150 every time. And that one does all kinds of weird stuff. So, all right, let's make this small again. Perfect. Good job. Let's go to page 2. All right, a sequence, we might see it in different forms. We were looking at just a list of terms. That's what we saw. That's the type of sequences. But we might see it in a table. And the way it reads in a table is n is the term number. This is the first term. The first term in our sequence is a 3. The second term in our sequence is a 6. The third term in our sequence is a 9. The fourth term in our sequence is a 12. So this is the exact same as this list. This list is the same as this table. It's the same as this graph. So the graph says the first term is a 3, the second term is a 6, third term is a... So this is 3, 6, 9, 12. 3, 6, 9, 12. It's just we're saying which term number it is. So you'll notice on the graph, there's not a continuous line through the points. That's a good point. There's no line connecting those because we don't have a 1.5 term. You know, like 4.5 is not part of the sequence. It's only a discrete. This is called a discrete graph. A set of data is discrete if it's finite or if there are spaces between them. Because this does not include any number between 3 and 6. If we connected that, it would include every number between 3 and 6. So this is different from a graph that has a continuous set of points. There are going to be 2 different methods for determining the terms of a sequence. One of them is the recursive. So let's talk about that. And we're gonna write down our first formula here as well. Arithmetic sequences. Okay, recursive. Not a word we use very often. The recursive way to find a sequence is if we want to know what a sub n is. And a sub n is whichever term. N is the term number. Like if I want to know the fifth term, right? Let's just give us a sequence to use up here. Let's say our sequence is 2. No, I don't want to do 3. I'm not doing ones. I'm changing. I'm gonna change it. Let's add 3. Let's make it 5. Let's move 8, etc. All right. So this is our sequence. Like if I want to know the fifth term of this sequence, I have to know what the fourth term is. If this is 5, 5 minus 1 is 4. And then I would add the common difference. A sub n is the nth term. N equals number of term. We'll say terms. D is the common difference. The common difference. So just so we have an idea of what we're talking about here. So in this case, if I want to know the fifth term, I need to know, so a sub 5, I would have to know the a sub 5 minus 1 or 4. 5 minus 1 is 4. Plus, what's the common difference? We can find the common difference by subtracting backwards. 8 minus 5 is 3. 5 minus 2 is 3. So in this sequence, D equals 3. So if I take the fourth term and I add 3 to it, that'll give me the fifth term. But the problem is I don't even know the fourth term in here. So I have to find the fourth term by taking the third term and adding 3. A sub 3. Well, a sub 3 is 8 plus 3. So a sub 4 is 11. So now I know this is 11. So a sub 5 is 14. So we can see how that works, right? That's kind of what we were doing on page 1. When we were looking at a sequence, we looked at each number, we figured out what the common difference was, and we added that to find the next term. Oh, the next would be 11, then it'd be 14, then it'd be 17. So this is all fine and good in finding the next term. This is not hard at all. This is the recursive method. Okay. But what if I want to know a sub 33? This is saying I want to know what is the 33rd number in that sequence. You're like, oh, please no, Mr. Brock. Please no. Because that means I got to find the 6th, the 7th, the 8th, the 9th, because I need to know the 32nd term. In order for this formula to work, to find the 33rd, I need to know the 32nd one so I can add 3 to it. So what's the 32nd term? Well, I don't know. I got to figure that out by finding out what the 31st term is and adding 3 to that. So we need another method. This is fine if we want to know the 4th, the 5th, the 6th. But if we want to jump to the 33rd, we're going to need some help. So this talks about recursive, means and which means again. So the recursive process is where each term has to be known and you keep applying it again and again and again until we get to the 33rd term. It's recursive. Again, we're going to keep going through the same step. Add 3, add 3, add 3, or whatever our sequence is. So we need a different method to jump to the 33rd because we don't have to find 32 terms to know what the 33rd is. So there is another way to do this. So there's something called the explicit formula, which means we can calculate directly. We can jump straight to number 33 and figure that out. So let's see, they're going to use, Okay, 2, 9, and 16 is what we're going to do. Let's see if we can figure out how to find an explicit formula. So looking at this sequence, we know 2, 9, 16, that the first term is a 2. And if we want to find the second term, what do we have to do? We have to take the 2. What's the common difference here? 2 to 9, 9 to 16. So the common difference is 7. So if we take the first term and we add 7, we get the second term of 9. And if we do the third term, and let's say every time we take the one above it, we take the first term and we add 7 to get this one, add another 7 to get this one. Right? So we had a 2, we added 7 to it, we got this one. We took this and added another 7 to get the third term. The fourth term, we're going to take the one above, and the one above was 2 plus 7 plus 7. We'll add another 7. So now we got 23. To get the fifth term, we took the 2 plus the 7 plus the 7 plus the 7, and we added another 7 to get 30. Well, what's another way of doing this? So this took the fifth term. It took the first term, a sub 1. A sub 1 is the first term. And it added 7 4 times, or 7 times 4. Right, because in upper level math, we don't do 7 plus 7 plus 7. We do 7 times 4. And this was, 2 plus 7 times 3. And this was 7 times 2, and that's 7 times 1. So we take the first term and do 7 times 4. How does that relate to the fifth term? Five minus 1 is 4. The n is right here. So let's just do generically. If we want the nth term, we could take the first term, a sub 1, add the common difference times, this is 1 less, n minus 1. 4 is 1 less than 5. We multiply by 3 here, that's 1 less than 4. We multiplied 2 7s here, which is 1 less than 3. We did 1 7. And here we didn't add any 7s at all. So our recursive explicit formula, sorry, we already had a recursive. We could find a sub n by taking the first term, multiplying the common difference times 1 less than n. So let's see if that works for the sixth term. So the sixth term would be 2, because that's what the first term is, plus 7 is the common difference. N minus 1, 6 minus 1 times 5. So 2 plus 7 times 5 equals 37. Would that be the next term? Yeah, look, this was 30. The next one will be 37. So this formula works. If we just take the first term and multiply the common difference by 1 less than the term we're looking for. We're looking for the sixth, take 5. So here is our explicit formula right here. So I'll highlight these. So knowing that, let's see if we can find this 33rd term. Common difference was 3. So the first term on this one was a 2. plus the common differences of 3, n minus 1. N is 33. So I'm going to take this times 32. So 2 plus 3 times 32 is 96. So 98 would be the 33rd term in this sequence. 2, 5, 8, 11, 14, 17. This will be the 33rd term. So these are the formulas you need. These are the formulas you need for arithmetic sequences. Let's see, those should be in our lesson as well here. So it's working to find out the same thing we did. 2 plus 2 times 7. 2 plus 3 times 7. So now it's saying, where did we get these numbers? Where's the 2 come from? That's the first term. Where was the 7? That was the common difference. How is the factor of 7 determined? The position of the term in the sequence minus 1. Fourth term, so 3 is the number we're multiplying by the 7. So 30 is the fifth term. And they have a little video where they show how to find the formula. Let me jump to the end, because we've already got this in our notes, so we're not going to take time to watch the whole video. If you want to watch the 1-minute video, you can do that. But a sub 1 equals the first term plus, and I put the d in front of it. It doesn't matter if the d is in front. You're multiplying two numbers. 2 times 3 and 3 times 2 is the same. N minus 1 times d, or d times n minus 1, as I wrote it. So here is the recursive. Here is the explicit. Look, they put the d in front on this one, just like I had written it on our paper. So here are the two formulas that you should have in your notes. A sub n, n minus 1, and d are in both equations. You just got to know where to use them at. So that is our equations we're using for arithmetic series, or sequences. I'm sorry, sequences. Let's look at page 3. They're saying really this is a combination of functions. You have a sub 1, which is just a constant, right? That doesn't change. The first term in the sequence doesn't change. Whatever that first term was, it's always going to be the first term for that sequence. It doesn't change at all. D times n minus 1 is a variable. It's going to change depending on which term you're looking at. N minus 1 is going to be different, because you're going to look for the 8th term, you're going to look for the 12th term, you're going to look for the 41st term. And so this part will always different. A sub 1 will always be the same. So let's talk about the domain and range of these. Well, let's think about the domain. The domain is the term number. The domain is the term number. Like when we saw it on a table, n was 1, 2, 3, 4, because it's the first term, second term, third term, fourth term. So if you think about the domain, here I'm going to emphasize this off the screen here. If we're thinking about the term number, that makes it real easy to think about what is the domain of a sequence. It's easier to think about what's not included in the domain. Well, there's not going to be negative numbers, because if I say, okay, here's the sequence 2, 5, 8, what's the negative third term? You're like, Mr. Brock, are you okay? There's not going to be a negative third. No, there's not going to be a negative third term. Negative third terms are just not there, right? So negative numbers are not part of the domain. Not part of the domain. So we know negative numbers are not part of the domain. How about decimals? Is there a 3.7th term of our sequence? No, there's not going to be a 3.7th term of a sequence either. That doesn't happen. So the domain is only going to be all integers greater than 0. There's not a 0th term either, so 0 is not included. But every integer larger than that there's a first, second, third, fourth, fifth. Sequences go on forever. There's a 1,000th term. There's a 2,000th term. So the domain is quite simply all integers greater than 0, or you could say greater than or equal to 1, because 1's the first term. So, and that doesn't ever change. Every sequence has a first term, second term, third term. None of them have a 2.3 term. None of them have a negative third term. None of them have a 0 term. Every time the domain for a sequence is all integers greater than or equal to 1. So, I'm going to make that straight up and simple. That never changes. All right, I'll put this back up on the screen. So it'll say it right here. A sequence is a set of numbers, and we count the terms as the first term, second term, so on. Not appropriate to have a negative term, a decimal term, a fraction term. The terms all start at 1. So basically, the domain is restricted to all integers greater than or equal to 1, which we call the natural numbers. The range, now the range we saw on those sequences at the beginning of the class, the range could be anything. Depends on each sequence, right? The range could be a decimal, because we had 1.25, we had 4.75. It could be a decimal. It could be negative numbers. We had negative 147, negative 297. It can be positive numbers, negative numbers. That's going to depend on each sequence. It can be any number. It doesn't have the same restrictions, right? Just depends on the sequence. But the range is only going to be the terms of the sequence. In the 2, 5, 8 sequence, 6 is not included, 7 is not included, only 5 and 8. So it will be not including every number. All right, they want us to work an example, and we have the lesson summary right here. What is? Oh, this is a good one to work too, because we need some practice with this. 46th term. Where A1 is negative 22, A12 is, what is that, 77. Okay, this takes a little work. So this is a good one for us to do together. All right, I've got it written right over here. Right over here. And we're like, okay, the 46th term. When I see 46th term, I think I want to use the explicit. I don't want to have to find the 45th, the 44th, the 43rd, every term up to the 45th. So I want to use this formula to jump straight to the 46th. So I'm looking for A46 equals, right? And to do that, I have to know the first term. Well, we have the first term. The first term is negative 22 plus D. Okay, I don't know D. I got to find D. D is unknown. And N minus 1. I know what N minus 1 is, because N is 46. But what I have to find is, what is the common difference? What's the difference between these numbers? Well, here's the nice thing. I know another number on the sequence besides just the first one. That means I can use this formula backwards with these two numbers. I know that A sub 12 is 77. And I know in the formula that A sub 1 was negative 22. And I don't know D, but I know N minus 1, since this was the 12th, I know this is 11. Look, I know everything but D. I can solve this problem for D. So let's add 22 to both sides. 99 equals D times 11 is just 11D. I can divide both sides by 11. And I get 9 equals D. Now I know what D is. So I can go back up here, substitute 9 in for D, and solve this. Negative 22 plus, let's get our calculator out so we don't make any mistakes. 9 times 45. 9 times 45 is 405. And I need to add that to negative 22. Or I can subtract 22, but I'll go ahead and add a negative 22. So 383 is the 46th term for this problem. 383. I just had to find what D was because it wasn't clearly just, it didn't tell us that. It told us the first term and the 12th term. But using the 12th term and substituting it into this explicit equation, I could find what D was because I had a sub n, I had a sub 1, and I know what n minus 1 was. So they find D the same way. 77 equals negative 22 plus 12 minus 1 times D, using that first and 12th term. Find out D is equal to 9. So then, knowing that, A46 equals negative 22 plus 46 minus 1 times 9, it is 383. Okay, that's not terrible. There's more examples. If you need more examples and you're not confident yet, there's another one. Here's the lesson summary. Has the arithmetic sequence formula. That is actually the explicit one. A sub n, A1, n minus 1 times D. There is the recursive one as well, where all you do is take the one before it and add the common difference. Talks about domain and range. Integers greater than or equal to 1. And the range is not restricted. It is restricted for a specific sequence, but in general, it's not. All right. There are some example problems here on page 4. Some practice for you. Find the indicated term. What is the 34th term of this 2, 7, 12 sequence? All right. So you do all your math, figure out, you can find common difference right there. It's common difference is 5, and you got the first term. So you just plug that in, work that up. There's 5 problems. What's the 16th term of this sequence? That sequence is going down, so it's not going to be a positive number. It's going to be a negative number. It'll be one of those two. So, all right. Then let's look at the assignment for this first lesson. We'll get to our second lesson. Identify the 42nd term, and they give you the first and the 27th. So that's just like the last problem we worked. You have to figure out what the common difference is so you can use the explicit formula. 27th term. Here's the first term and the 17th. The seats at a baseball stadium are arranged so each row has 5 more than the row below. 5 more. There's your common difference. Every row is plus 5. The front row has 4 seats, which means the second row has 9 seats, which means the next row has 14 seats. How many seats are in row 23? Just because it's the word problem, don't get that confused. You know the first a sub 1, you know the common difference, and you know which number they want. They want the 23rd number in that sequence. Okay, it says, all right, if we have the function f of n equals 11, which is the constant part, which is a sub 1, and this part, negative 2 n minus 1, that's the common difference. Combine them to create one equation, which all you do is add those together. 11 minus 2 and n minus 1, and then find the 31st term. Just substitute 31 in there, and which one of these is correct. And here they give you a sequence in a table. First term is 9, second term is 3, third term is negative 3. Which one of these would be the arithmetic formula? And what's the domain? The domain is n is less than or equal to 9, or n is greater than or equal to 1. You should be able to eliminate half the answers just knowing the domain. The domain. All right, 5 problems. That's not bad. Yes, I know. Leave. Let's go look at arithmetic series. Arithmetic series are related to sequences. There's just a little bit of difference. So let's say you start a bank account and you make your initial deposit of $25. I think when I was a kid, I opened my savings account with $28. I got it for my birthday. I got 5 fives and 3 ones. I remember taking a picture of it somewhere in a box. I've got a picture of $28 that I took when I was like, I don't know, 8 years old. Opened up my first bank account. So $25 every month for the next 5 years. You increase your deposit amount by $15. Not including interest. How much is in the account? How much at the end of 5 years? How much is in the account? So your knowledge of arithmetic sequences will help you find out how much is in there, because you put $25 in, and then next month you put in $40 because you increased it by $15, and then the next month you put in $55, and then you put in $70 because you're making more and more money each month. So how do arithmetic sequences and series differ, and what information must be included to find the sum? This is going to be the big difference here. An arithmetic series, all right, a series similar to an arithmetic sequence is a list of numbers called terms that share a common difference. But here's the big difference. Well, let me emphasize this again. In a sequence, we're just finding the next number. In a series, we're adding all of them together. If it's 2, 5, 8, it's like, okay, 2, 5, that's 7, plus another 8. Now we're up to 15. And however many terms you include, you add all of them together to have one grand total. That makes it a series. We're taking a series of numbers and adding them up. The sequence is just finding the next number. So that's the big difference. So we're going to learn formulas. So we're going to have 2 formulas to write down this as well, to be able to add them together. So you start with a sequence and you add it together. We, just like the last one, we have another little drop box here. And we need to know, is this a series or is this a sequence? Remember, a series, we're going to add them all together. A sequence is just a list of numbers. So if we have 4 plus 14 plus 24 plus 34, is this a series or a sequence? This is our new thing we're learning. All right, jump out there. Be brave. Be the first one to answer. Okay, Alexander said this is a sequence of numbers. Anybody else? Anybody else? Okay, everyone's going to go with you. Alexander, sequence? Sequence? Let's see. The terms in an arithmetic series are being added rather than separated by commas. I'm going to highlight that and then go back and show you this list of numbers that says 4 plus. Yeah, this is the difference. We just got to look at the sequences. A series is when we add them all together. All right, how about this one? Is this a sequence or is this a series? Yeah, this is the exact same sequence we had in the sequence lesson, actually. Well, it's just got commas. We're not adding them. We're just listing them. We're just listing the sequence of numbers. How about 1, 2, 3, 4, 5? Yeah, this is actually the very first sequence of numbers you learned back when you were in grade school. You learned how to count starting with 1. 1, 2, 3, 4, 5. That's a sequence of numbers. How about this list of numbers? 10 plus. Yes, there you go. You guys are getting it now. Now we're getting the hang of it. Now we're getting the hang of it. I do want to thank Alex for jumping out there first and being brave enough to throw an answer out there to get us started about this conversation. So that's great. Do we have another one down here? No, this is a video down here. Okay. I'll go ahead and make it smaller again. All right, now we know the difference between a sequence, which is just a list of numbers, and a series, which means we're adding them together. So let's take a look at our first series and see how they add them together to get one total at the end. I don't think there's any sound with this. So let's talk about it as it goes through. All right, so here's what they did. Did you see the first thing they did? they took, where's it at? Go forward a little bit. They took the first number and the last number, 4 and -11. They take those and they're adding them together. 4 plus -11 is -7. Well, that's interesting. Hadn't thought about adding a series together that way. We would have probably done 4 plus 1 plus -2 plus -5. They're doing the first and the last because they have a series of 6 numbers. Let's see what they do next. Now they took, the second one and the next to last. Look, the 1 and the -8. And when they add those together, that also equals -7. So now they're taking the middle two numbers, -2 and -5, and add those together. Okay, that kind of leads to something interesting. We got -7, -7, -7 when we took the pairs from the ends and added them together. So we notice that each of them added up to -7, and there's 3 of them. So -7 plus -7 plus -7. So this must add up to -21. That makes sense. If these all add together to be -7s, and there's 3 of them, the whole group of them must add up to -21. But that kind of gave us an idea of a formula. All right, let's review this real quick. This is just our vocabulary to make sure we still remember what's what. The last term of a finite sequence, because we just looked at sequences. So should have a good idea on this. The last term, would that be D in A sub 1 or A sub n? Well, the last term would be A sub n. If we have a 6-term series, A sub 6 would be the last term. All right. The common difference. What's the difference between each term? That's D. We use that in our formulas. D is the common difference. The first term is A sub 1, right? We know A sub 1 is always the first term. And N is the number of terms in a finite sequence. That means if we limit it, talk about the first 8 terms, 8 is N, right? In a finite sequence. Okay. Just to review our vocabulary as we go forward. So using some or all of these variables, we want to write a mathematical expression that would allow you to find the value of -7 using this sequence they did above. All right, I'm gonna write down what they did because we're gonna build this formula using those numbers. Okay. So this was that sequence of numbers they had, the series of numbers, 4 plus 1 plus -2 plus -5. And they took, these 2 terms here and they added them together to be -7. And then they took these 2 terms here and they add those together to be -7. And then they took the middle terms here and they add those together to be -7. So altogether, we've got 3 times -7. Now, how can we derive a formula from this? So we have a series. Now, by the way, with a series, we don't use A, we use S because we're getting the sum. We're adding them up. The sum of these 6 terms. This is a 6-term series. So the sum of those 6 equaled what? The common difference was -3, so that had nothing to do with that. But they ended up multiplying by 3, and we had 6 in there. So can we say 6 divided by, 6 divided by 2, because it took 6 of them, divided by 2 gave us the 3. And then they add A sub 1 plus A sub 6, right? Which was 4 plus -11. Does that work? So would our formula be the sum of any number would be the number of terms divided by 2, because we're breaking them up in pairs, times the first term plus the last term. Because that's what they did. Let me change this here. We took, what we did is we took the first term, which was 4, and we added negative 11. 4 plus negative 11 was negative 7, and we multiplied it by the number of terms divided by 2, because we cut it in half. Negative 7 times 3. So I think that works, which would give us this formula for any series. The number of terms divided by 2, take the first one and the last one and add them together and multiply that. That'll give you this. I think we've got it. Let's take a look at what they come up with on their lesson. The expression's a1 plus a sub n by adding the first and last. And then there are 6 terms, and they did n divided by 2. So if we go to the next page, I think they put those together and give us the formula. Oh, they're going to work backwards now. Okay. They're going to do it with the video. So we'll let them do it with the video. But I think we've got it. We've got exactly what they're going to come up with. Let's see how they explain it.
The sum of the 6 terms of the arithmetic sequence is negative 21. Negative 21 can be rewritten as 3 times negative 7. 3 represents the number of pairs in the arithmetic series, and negative 7 is the result of negative 21 divided by 3. The 3 pairs in the arithmetic series can be written as 6 divided by 2, where 6 represents the number of terms in the series. Negative 7 can be written as 4 plus negative 11. 4 represents the first term of the series, and negative 11 represents the last number of the series.
All right, we had it. The number of terms divided by 2, which because we're pairing them up, first term and last term. This is our formula that we now have. So there it is, the arithmetic series formula. S of n equals n divided by 2. I'm just going to highlight that. And I'm going to write in my notes. I'll show you in just a second. I just had that over there. This is an arithmetic series formula. Series. N divided by 2. And it uses an S instead of an A because this is the sum. It's not a particular term. It's the sum of all the terms. Arithmetic series. There we go. Okay, then it has an example where we apply the formula. Oh, so we're developing another series. Okay, apply the formula right there to get the negative 21. But sometimes the sequencer series may be too long, right? Maybe they don't give us the whole 6. Like if we got a sequence that has 40 terms in it, we want to add all of them up. It's not going to list all 40. We may not know the last one. So let's modify our formula based on that. So if we don't know, here, let me switch over here. If we don't know a sub n, because we might not, we had a formula to find a sub n over here. Right, a1 plus dn minus 1. A sub n equals the first term plus d times n minus 1. So if we take this, it's like if we don't know the last term, they just list this many, and then they say dot, 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 and we want to add up the first 20. It's like we don't know all of that. We can take this and let's substitute it in. Let's work on this. The sum, the series sum would be n divided by 2 times A1 plus, if we don't know that, let's use this. This is what it equals. A1 plus D in minus 1. Right? We just simply took this right here and substituted it in for A sub n. So A1 plus this instead of that. So now we need to simplify this. What can we simplify? We have A1 plus A1. It could be n divided by 2 times A1 plus D n minus 1. So n divided by 2 times the first term plus D minus n minus 1. Let's see, is that what they gave us then as our final? Yes. N divided by 2 times the first term plus the D times n minus 1, or n minus 1 plus D, whichever way. So this is an alternative if we do not know the last term. Last term unknown. So if the last term is unknown, this formula will get it for us. So that's the two. If we know the last term, we can use this one. If we don't know the last term, we can use that one. So either way, we'll be able to solve our series problem based on one situation or the other. All right, so let's see. And then they used this same one using this formula, knowing there's still 6 terms, so 6 divided by 2. The first term is still 4. And the common difference, though, this time is it's going down 3 every time. 4 to 1, negative 2, negative 5. The common difference is negative 3. So they substitute negative 3 in there. So 6 minus 1 times negative 3. This simplifies to 3. 2 times 4 is 8. 5 times negative 3 is negative 15. So 8 minus 15, you get to the negative 7. You still get 3 times negative 7, and it does equal negative 21. All right, let's go to page 4, see what they're going to show us over here. There's our lesson summary right here. It gives us our 2 formulas for arithmetic series. This one when we know what the last term, this one when we don't know the last term. So here it is. If you have a printer and want this to be your notes, it's got both your formulas right there. You can print those out and keep that with your notes. Let's look at some examples. All right, so this one tells us to find the sum of a 26-term sequence. The first term 6, last term 231. So they gave us the first and last term and said find the sum if we add all these terms together. So we can use this because we know the last one. So we can say the sum of the 26 terms is 26 divided by 2, because our n is 26, times the first term is 6, the last term is 231. So the 26-term series adds up to be 13 times 237, which again, we're going to let our calculator do all the heavy lifting for us here. Put it over here. 13 times 237. Oh, I missed a button. 237. 3,081. That's pretty good number. All right, let's see how that compares to what they have in their answer. 3,081. It's just a matter of just plugging in the numbers and then doing the math. Let's see example 2. Let's see. If you were given a series of 23 terms, which is 5, 7, 9, etc., and want to find the sum, which formula would you use? Well, you'd have to use the second one because you don't know the 23rd term. Right? So you use that n minus 1 times d formula. Okay, so here's one where they want us to find the sum of this sequence, 11, 18, 25, if there are 31 terms. So let's do that ourselves on paper before we see how they had on their video. 11, 18, 25, dot, 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 and it says 31 terms. 11, 18, 25, 31 terms. So we don't know the 31st term, so we're going to use the second formula. So the sum of these 31 terms is going to be 31 divided by 2. Yes, that's not going to be a nice number, but our calculator doesn't care. Times 2 times the first term, which the first term is 11, plus what's our common difference? 11, 18, 25, so it's obviously plus 7. We can subtract. 18 minus 11 is 7. 25 minus 18 is 7. So every time it's adding 7. 7 times n minus 1. Well, again, the n was 31. So if I subtract 1, so this equals 15.5. 31 divided by 2. 2 times 11. 7 times 30. So this equals 15.5 times 232. All right, let's see what that adds up. Get our calculator out here again. I'll say 15.5 times 232. So it adds up to be 3,596. 3596. Let's see what they get in their video. But we're saying 3596.
Since you don't know the last term of the sequence, but can find the common difference, you will use the formula S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. First, define each variable. There are 31 terms in the sequence, so n equals 31. The first term is 11, making a sub 1 equal to 11. Finally, find the common difference. The common difference between each term is 7. Now simplify. The sum of the arithmetic sequence 11, 18, 25, and so on, if there are 31 terms, is 3,596.
All right, that's the same number we came up with. So, all right, there are more examples there. Looking at a savings account, so which formula, if you had $25 in your next 5 years, you increase your deposit by 15. What's it worth at the end of 5 years? It wants to know which formula you'd use. Well, we don't know the last deposit, so you'd have to use that one. Good job. And it'll walk you through that problem as well. What is N? Well, N would be each month for the next 5 years, so that would be 60, right? N, because we make 60 deposits in 5 years. What's A sub 1? Well, that's the very first deposit. Then it says, what's D? Well, every time we're adding $15 to our deposit. And it says, not including interest, how much is it worth after 5 years? Well, we could do the math. I'm not going to get the calculator on that, but we just walk through it one by one. Here is a sequence of letters that goes 6, 8, 10, 12. See, the first term is 6, the second term is 8. So this is a simple sequence where it's just adding 2 each time. She was told by the bride to add 10 more rows, right? So it was 5, 6, 7, 8, and figure out how much you need. the sum. How many chairs do you need to order, right? If you could have 6 chairs, 8 chairs, 10 chairs, 12 chairs, but have 14 rows, you need to add up the total. So you can use that formula, and you need 266 chairs. So, all right, examples there. There is a page of practice problems. Oh, 2 different sets. What's the sum of a 44 term? First term -9, last term 120. They give you the first and last. So you can use that first formula to figure that out. There are 4 problems. Activity 2 has first term of a 14 term. What is the first term? They want to know what the first term. You got to work different. Oh, let's work this one together. That looks interesting. Okay. Okay, so I wrote that down. We need to know a sub 1. We can use this formula because we know the last term. So I'm going to write that formula down here. N divided by 2 times a sub 1 plus a sub n. And we're kind of working backwards. We're going to fill in everything we know here, which we know the total. So it's 42 is what the sum equals. We know n divided by 2 because we know there's 14 terms. So this is a 7. 14 divided by 2. We don't know what a sub 1 is, but we know what the last term is. It's -12. So minus 12. We're trying to solve this for a sub 1, which is fine. That's the only variable. We have all numbers. So let's distribute the 7. 42 equals 7a sub 1. And 7 times -12 is minus 84. So I guess I don't need the parentheses anymore. 7a sub 1 minus 84. So if we're going to solve this, add 84 to get the a sub 1 by itself. So we've got 126 equals 7 a sub 1s. Divide by 7. And that'll tell us that a sub 1 equals, well, the calculator to build the suspense. 126 divided by 7. 126 divided by 7 is 18. 18 is the first term. So we just had to pull up the formula for the information we had. If we didn't have the last term and had the common difference, we'd just switch to that formula. But since we knew total, we knew the number of terms, we knew the last term, we could just substitute what we know and solve for the unknown variable. Solve for the unknown variable. That's a good one. So what did we say it was? 18? Correct. And then it shows you how to work. So there are 4 of those problems. What's the common difference? This one doesn't know the common difference, but you have the sum and you have the first term. So you use the second formula to find out what the common difference is. All right, let's look at our assignment that goes with this. I'm going to finish a little bit, give you a little extra time here to start. The first and last terms of a 10-term sequence are listed. Here's the first term, here's the last term. What is the sum of the series? Add all those terms up. It doesn't list 2 through 9, but we don't need that. We have a formula. You have a formula. What is the, identify the 33rd term. Well, that actually goes back to the first lesson. This is not asking you to add anything up. This is, so this goes back to the last lesson, really. Find the 33rd term. See, Jennifer's been saving for college. The first month she had $11. She was able to save more money each month and ended up with this much. So how much more? So they're wanting you to find the common difference. Use that second formula, find out which one of these is the common difference. Each trip, a bus drops off more fans at a concert. On the first trip, it drops off 30. On the 14th trip, which was the last one, it dropped off 95. That's a really big bus if it holds 95 people. Wow, school buses only hold like 60, 65. So this is a huge bus. What if it's a double-decker, like one of them British buses? How many fans did it deliver in total? So you're adding up this whole series. There's 14 trips. You know the first trip. You know the last trip. So you can use that first formula. The windows of a downtown office building arranged so each floor has 6 fewer. There's your common difference, -6, than the floor below it. If the ground floor is 52, how many total windows are on the first 8 floors? So you know the common difference, you know the first term, you know how many floors. You can use the second formula and do that. So there it is. Got 2 lessons, very closely related. One's just talking about a sequence of numbers, find the next number. The second one says take those numbers and add them all up. That's our arithmetic series. So next week, we're going to look at geometric sequences and series. Like geometric, yeah, exponential. It goes like 1, 2, 4, 8, 16. We're going times 2 each time. That'll be next week. This week is simply adding the same number every time to get to the next number. So if you have any trouble with this, I will have class on Thursday. You don't have class on Thursday unless you want to come, because nobody's grades below 70. You know, your grades just going to start with this week. So this week's assignment's the first thing in the grade. So it's optional for you Thursday, is what I'm saying. But I'll be here. If you're having trouble, you work on this, you're like, oh, I thought I understood. I don't. Let me go see Mr. Brock. Come to class, get some help, then you can leave class when you're done. So whenever you get your help and you're ready to move on. But otherwise, I won't see you till next week. Next week, Monday is a holiday, so your A-Day classes are going to move to Wednesday. So don't forget that. No school on Monday. But it doesn't affect us. We're a Tuesday class. So see you guys next Tuesday. Give you a few minutes, you can get started on this before your next class for advisors.